I don't know who I'm writing this to or why. It's the end of the world after all, so everybody knows all I have to say anyway. But somehow, I feel that I have to tell this to someone. So, it began as slight jolts from under the ground. Nobody really paid attention to them, especially in seismically active regions. People thought these were just minor earthquakes. They talked about them in the news, but only few actually cared. My parents, I was only 12 back then, were among those who did, but let's save it for later. In just a year, the jolts became much stronger and more frequent. In some areas, they turned into full-fledged earthquakes, doing a lot of damage to cities and villages. Worse still, previously dormant volcanoes began waking up. All over the world, people started raising alarm. Scientists talked a lot about climate change and impact of humankind, but it was obvious nobody really had any definitive answers. It didn't get any better either. As months went by, earthquakes and volcano eruptions gradually grew in power and frequency. At first, only one major natural disaster per month was reported. But in 2 more years, there were at least 4 of them occurring within the same period in every corner of the world. Even the normally calm regions suffered from quakes and resulting tsunamis. People tried to adapt, but it was all unfolding too fast for us to react adequately. All we had left to do was to learn to be always ready to move out from our homes and run. We stopped building big and sturdy apartment buildings, opting for lightweight 3D printed houses. They were easily destroyed but easily built too, which was a huge advantage. Items of luxury were rapidly losing their value, while on the other hand, mobile electronics and survival tools grew in price. People began really appreciating what they had and each other. Neighbors were helping one another, and whole towns unified their efforts to build strong communities and prepare for the worst together. And the worst came sooner than we expected. One day, the whole planet was shaken in one titanic earthquake. We thought it was the end for us all, because the ground went on shaking for hours and didn't cease until the next day. And then came reports from the Atlantic coast. The ocean receded, leaving vast swaths of naked sand and corals. Research teams on helicopters went to learn what caused this cataclysm and found the unthinkable. There was an enormous whirlpool in the middle of the Atlantic, hundreds of times bigger than the largest sinkhole in the world. The water from the ocean was gushing down the gigantic drain, as if someone pulled the plug on the bottom. In a sense, that was exactly what happened. Tectonic plates beneath the Atlantic came apart, forming a huge gap in the bottom. Boiling magma poured out, but was extinguished by the overwhelming mass of water, which then rushed down into the abyss. It went away so quickly that the overall water level fell in a matter of hours. The event was dubbed the Great Atlantic Rift, but it was still only the beginning. With the rising frequency of earthquakes and eruptions, wind patterns around the world changed, resulting in massive hurricanes. It seemed the whole planet was against its inhabitants. But like I said earlier, my parents were the ones who cared, and they had to know the reason. They were geologists at the International Space Agency, which continued its work even through all the cataclysms. And it was them who came to the distressing conclusion. For some unknown reason, the Earth had started to grow in size. It would explain everything. The ever more frequent earthquakes were caused by tectonic plates come into motion. The flowing magma was pushed from the mantle up towards the crust and burst onto the surface in places suited exactly for that – volcanoes. And that meant there would be other events like the Great Atlantic Rift, only even more catastrophic. After another year, we moved to live in the agency, along with the families of other employees and research workers. The buildings were made to withstand almost anything, so we were protected from the horrors of the outside. We took in as many people as we could, but of course, it wasn't nearly enough. Millions more were left to their own devices, and we could only hope that everyone was safe. By that time, as scientists estimated, the planet had already grown 1.5 times its original size, and by the looks of it, the rate at which it ballooned was growing. In another year of our bunkered life, we witnessed it grow twice again. Rifts even bigger than the one in the Atlantic popped up in different parts of the world, causing widespread chaos. Everyone went to live underground where it was relatively safe. Communications between continents were all but lost, and all we learned about the situation above was from daring expeditions by scientists. The planet was ravaged by quakes, volcanic eruptions, tsunamis, and hurricanes, happening almost daily now. Life on the surface was virtually impossible. It was then that the joint team of researchers and engineers suddenly came out with the solution they'd been working on for the last 5 years. They called it the Ark. It turned out several teams agreed to build huge spaceships to evacuate humankind, along with the surviving animal, fish, and insect species in case the Earth comes apart. And the time they'd feared finally came. Everyone in the agency's buildings, including me and my parents, were escorted to an enormous hall where one of the arks was kept. All other people from the continent who managed to come were also there. We were given personal IDs and then allowed to board. Each person was allocated a separate capsule that was to keep us hibernating for the whole time of space travel. We were told we were the colonists, the pioneers in space settlement. We were going to Mars. And that's how I ended up here, where I'm writing all this. We successfully boarded the Ark and were put to sleep in our capsules. When I woke up, we were already landing. I won't bore you with the details of terraforming and settling in our new home. At first, we all wore special suits equipped with oxygen tanks. But soon enough, we built a dome with artificial atmosphere and started making the territory suitable for living, both for us and for the animals we brought. Since then, 10 years have passed already. We're feeling almost at home on the red planet, which isn't really red anymore. There are lush forests and big cities sprawling all around. Mars is inactive, so there are no earthquakes or hurricanes here. Life is pretty peaceful, although it's as busy as can be with all the work that still has to be done. But all this time, we've all been anxiously watching our home planet grow in size. At first, it was barely visible in the night sky, but as months passed, it became more and more apparent until one day it could be viewed in some detail with an unaided eye. Today, it's the size of the moon in our skies and visible even in the light of day. The sun is much smaller from here than it was seen from Earth, so basically, our home planet is now larger than its star. Through telescopes, we can see its surface covered in scars and fissures dozens of times bigger than the Grand Canyon. There are no more seas and oceans, and continents drifted far apart. The once green and blue and welcoming world is now a barren wasteland, boiling with fire and brimstone. The sun isn't helping it either. When the planet was small, the star bathed it in its light and warmth, giving it life and energy. Now, when Earth is 100 times larger, the sun is scorching its surface and burning off the remnants of its atmosphere. But even that's not all. With the size, the gravity has grown too. Being so big and massive, Earth has collided with the Moon, virtually eating it up. Venus, which was similar to the previous Earth, started to be tugged toward the suddenly grown planet and was soon to run into it as well. And Earth itself is slowly gravitating toward the Sun. Scientists say that one day it would first consume both Venus and Mercury and then get burned completely in the Sun's heat. Wow. All I can hope now is to never see it with my own eyes. Okay, imagine there's a huge hot ball hidden inside the Earth. It's floating in an ocean of molten metal. This ball also spins on its axis, but it moves faster than the rest of our planet. This is what the Earth's core looks like. The solid metal ball is the inner core, and it's 750 miles thick. That's roughly the distance between New York and Chicago, and the whole thing is made up of hot iron and nickel. The outer core is the molten ocean. To reach the edge of it, you'd need to dig a tunnel into the Earth that was about 3,700 miles long. But you would hardly want to go there because it's the hottest point on the planet. The core temperature is 11,000 degrees Fahrenheit. That's greater than the surface temperature of the Sun. Another incredible thing about this place, the gravity at the outer core is 3 times stronger than that at the Earth's surface. This means that If we could somehow find a way to live near the core and you threw a stone there, it would fall 3 times faster than normal. It would become 3 times heavier. You would also become 3 times heavier. Now that doesn't bother you so much because things far worse will soon happen. Living conditions in the core would be the exact opposite of life on the International Space Station, and it'd be a lot harder than living on the surface. It would be difficult for you to even hold a fork in your hand because of just how heavy it would feel. Eating lunch would become a serious challenge. You'd break into a sweat just from writing with a pen on paper or typing on a computer. But if people could ever get used to these conditions, they'd become a lot stronger. Humans have learned to use the heat coming from inside the Earth as a source of energy. Some companies use this energy to heat water, which creates steam. This steam is used to power turbines that produce electricity. If the core ever cooled down and that heat disappeared, this kind of electricity might become very expensive. Some parts of Earth might become very dark, as people went back to using candles and fires to light things up at night. And you could forget about using your electric car as well, because charging it up would be just too much money. Phones, computers, the internet, all these things would cost a lot more. But this would actually be the least of our worries. Oh, just wait for it. The hot core's rotation creates the Earth's magnetic field. This field is like a shield that protects us from the sun and outer space. If the shield disappears, solar and cosmic radiation would pass through the atmosphere. The electricity supply would become seriously unstable. Microwaves, televisions, kettles, traffic lights, and computers could all be damaged. The screen of your laptop or phone would turn on and off randomly. Videos could freeze, and the batteries could run out in a second. Satellites would stop working, which means there wouldn't be any GPS system to rely on anymore. Say goodbye to navigating with your phone's map. Radio equipment would also stop working, so you wouldn't be able to make calls or send messages. Even now, when our magnetic field is working normally, solar flares can still create magnetic storms that disrupt electronics and affect people's health. Some people are sensitive to these storms and can get really bad headaches. If the magnetic field disappeared completely, every person on the planet, along with plenty of animals, would get seriously painful migraines. Scientists would have to invent special helmets that protect people from exposure to the magnetic storms. If the core cooled down and you became lost in a forest, it would be really difficult for you to find your way home even with simple equipment. Without the magnetic field created by the active core, your compass needle would no longer show where north, south, east, and west were. You would see the birds in the sky going crazy. They wouldn't know what direction to fly in for the winter, because south would no longer exist. In fact, no animal would be able to migrate anymore. In the sky, the location devices on planes would stop working. That means no more air travel until people find a new way to navigate. But hey, let's look on the bright side, because that's what we do here. You wouldn't have to go to the North Pole to see the northern lights anymore. Auroras would appear in the night sky everywhere. These occur because charged solar particles run into the magnetic lines stretching from north to south. But these lines will disappear if the Earth's core cools down, and the particles will light up the sky all over the world. A frozen core also means the tectonic plates will stop moving. There will be no more earthquakes anywhere in the world. But that's not as good as it sounds. The movement of these plates creates faults on the Earth's surface. They give us access to important minerals. With no more movement, producing fuel could become a lot harder. The price of gas might go up. Most people would have to stop driving their cars. There would be a lot more bikes and horses on the road, maybe some llamas. Volcanoes would also stop erupting. If the core cools, the magma cools. People who live near large active volcanoes would no longer need to worry so much. But there would be a downside to this. Volcanoes contain a huge amount of useful substances and minerals. The soil around volcanoes is very fertile, which is really good for agriculture. So more people would now have to eat artificially created food. There would be big problems with the supply of natural food products. Only rich people might be able to afford that classic tomato and cucumber sandwich. But the worst thing would be the long-term exposure to radiation, which is seriously bad for our health. More radiation means that the risk of getting diseases would be much higher. People would have to build special shielding to protect themselves from solar radiation. It would be way too expensive to cover the whole planet with this technology, so we just create separate shields for each city. Just imagine the side of every city covered by a huge protective dome. In this radioactive world, movement between cities would only be possible in special closed transport. People would need to wear protective suits. You wouldn't be able to go to the countryside anymore. Anyone still living in a village or a small town without much funding would be forced to live underground to protect themselves. Plants and animals would also have problems. Herbs, flowers, and trees would receive huge doses of radiation and wouldn't be able to bloom. Livestock wouldn't be able to eat grass and hay. Milk, cheese, and yogurt would be in real short supply. Plants would have trouble producing oxygen. The magnetic field not only protects us, it protects our atmosphere. A frozen core and no magnetic shield means that the solar wind would destroy the atmosphere in a few hundred years. The conditions on Earth would be changed completely. Humanity would no longer venture outside its protective domes with their artificial atmosphere. Instead, we'd have not only our cities, but also the last surviving pieces of nature, our trees, lakes, grass, meadows, and flowers. Everything left outside the domes would turn into a scorched desert. This is what happened to Mars. The red planet has no seas, oceans, and lakes. Some scientists believe it's completely dry because its magnetic field disappeared. With no protection, Mars lost most of its atmosphere, and the sun's wind swept away all the surface water. But of course, this is just one of many theories. This took place billions of years ago, and no one can say exactly what happened. But don't worry, our planet won't turn into Mars anytime soon. The Earth's core is cooling very slowly. It will take another 2 billion years or so before it cools down completely. What's weird though is that our magnetic field can be unstable even today. In the southern hemisphere, there's a spot where the magnetic field is weak. This place is called the South Atlantic Anomaly. Charged solar particles flow through this spot, which can cause problems for orbiting satellites as they pass through. There are some other places like this around the world, but fortunately, they don't cause us any really big problems. Good thing. Not so long ago, astronomers discovered a planet that got the name of UCF 1.01. This world is about 33 light-years away from Earth. This makes the planet our next-door neighbor, in the cosmic scheme of things, of course. Honestly speaking, the space body is only a planet candidate because astronomers haven't measured its mass yet, but they have high hopes. The wannabe planet is very different from our Earth. Just 1.7 million miles away from its star, it completes its orbit in a day and a half. It's a scorching, deserted world with the temperatures at the surface rising up to 1,000 degrees. Even more astounding, the entire planet is likely to be covered in magma. Even if UCF 10 ever had an atmosphere, it has definitely boiled away by now. But then, the question is, what if Earth once went through some catastrophic event and it left our planet in the same state, boiling hot with the surface covered by a thick layer of lava? Would people manage to adapt to such conditions and move to live underground? It sounds unbelievable, but experts are sure that with time, humans would turn into healthy and rather happy mole people. Of course, life would be very different than today. No more sunsets and sunrises. No more traveling by plane and space exploration, unless people found a way to launch a rocket from under the ground. No more picnics in the park or sunbathing at the seashore. People would have to build a vast network of underground tunnels that would connect major cities. The most likely transport in this new world would be silent high-speed trains and electric cars. After moving underground, people would have not only physical but also psychological difficulties. In the beginning, their new home would be a dark, barren place, without fresh air and devoid of any color. To adapt to these tough living conditions, people would have to make some design changes. Greenhouses, well-lit parks with trees and illusions of the sky, familiar scents and sounds. All this would help people to adjust to their new life. After living underground for several generations, people would start to look a bit different. Pale because of the lack of sunlight, with sensitive large eyes adapted to dimmer lighting and more developed lungs. As for the very possibility of living underground, well, hear me out. You might imagine the Earth's depths as a huge mass of compressed solid rock. But the reality is different. This mass is heavily cracked. Water runs down the fractures and cracks in the planet's outer layer, the crust. Some of these streams reach the depth of many miles. In other words, subsurface Earth could probably support plant and animal life. If people lived underground, they wouldn't have a shortage of fresh water. Its reservoirs in the planet's interior contain 100 times more water than all the lakes, rivers, and swamps combined. Plus, this water trickles through the soil that acts as a purifier. But people would have to be super careful to keep the sources of water intact. Otherwise, the underground cities would get flooded and turn into giant water-filled traps. It would also be a great challenge to live without sunlight. Plants can't survive without the sun's ultraviolet light. It's absolutely necessary for photosynthesis because sunlight is used to get nutrients from carbon dioxide in water. One of the byproducts of this process is oxygen, the thing people can't live without. So, no sunlight equals no plants equals no oxygen. Sunlight is also crucial for humans. For example, it helps your brain release serotonin, a hormone that boosts your mood and makes you feel focused and calm. Thanks to the ultraviolet B radiation in the sun's rays, your skin produces vitamin D. It's vital for a strong immune system and healthy bones, teeth, and muscles. That's why people would have to find a replacement for sunlight. Luckily, LED lamps that can give off UV wavelength could produce the light human bodies and plants crave so much. In the new underground world, there wouldn't be large sunlit fields. Instead, there would be sprawling greenhouses with LED lights shining from the ceiling. Special machines would feed plants and crops with recycled water rich in nutrients. In some areas, located in the narrow underground faults, people would use something like shipping containers instead of greenhouses. These containers would be packed with vertical rows of plants and blue and red LED bulbs. As for people, they would have to follow a vitamin D-rich diet. It'd mean eating a lot of egg yolks, cheese, fish, spinach, soybeans, and so on. If these foods weren't enough, vitamin D supplements would do the trick. Without daylight, people would have problems with their circadian rhythms that regulate sleep patterns. If you were isolated somewhere without a glimmer of light, you would easily sleep for 48 hours at a stretch. That's why people living under the Earth's surface would rely on artificial lights to control their internal clock. There wouldn't be any problems with electricity. It would be produced with the help of the Earth's inner heat. Such kind of energy is called geothermal, from the Greek words geo, earth, and therm, heat. It can be extracted from hot water and rocks. Like an onion, our planet is made up of several layers. The innermost part is a solid core around 1,500 miles across. Made of iron, it's surrounded by a scorching outer core. It's up to 1,400 miles thick and is mostly composed of liquid nickel and iron. The next layer is the mantle. Even though lots of people picture it as lava, the mantle is actually rock. But this rock is so hot that it flows, just like road tar. The temperature in the Earth's core is as high as 10,800 degrees Fahrenheit. That's almost 1,000 degrees more than at the sun's surface. The mantle is also blistering, from 7,000 degrees at the boundary with the core to 400 degrees in its outer parts. No wonder people wouldn't have any difficulties with transforming all this heat into electrical energy. But because the insides of our planet are insanely hot, people wouldn't be able to build cities too deep underground. All inhabitable areas would most likely stay closer to the surface. The Earth's outermost part, the crust, is like the shell of a hard-boiled egg. It's broken into gigantic blocks called tectonic plates. When two plates collide, mountains get formed and new rifts appear in the seafloor. They have different width, from 25 miles thick beneath the continents to 5 miles thick beneath the oceans. These blocks travel around, floating on the Earth's mantle, slowly, almost imperceptibly. It means underground cities would also move, but it would be next to impossible to notice these movements. Oh, by the way, people started to believe there might be another world inside our planet in the 17th century. The idea got the name of the hollow Earth theory. It claimed that half the planet was taken up by its surface weight. Below the surface, there was some empty space. A small sun hung at the very center of that cavity, creating a comfortable tropical environment on the inner side of Earth's surface. One could enter the Earth's interior through one of the openings near the south and north poles. A race of advanced humans was believed to live inside the planet. They were peaceful and lived for centuries. Well, obviously not humans. They had unique technologies, for example, flying vehicles. And since the climate inside the planet was better than that on the surface, this race was much stronger and healthier. Even though this idea sounds like science fiction, several famous scientists supported it. Some people are still sure there's another world inside our planet. But if the Earth was hollow, it wouldn't have a magnetic field. And without a magnetic field, solar winds would rid our planet of its atmosphere in the blink of an eye. This would leave our green planet deserted and uninhabitable, like Mars is. The magnetic field on our planet exists thanks to the processes going on in its very much not hollow center. Liquid metals are constantly moving in the Earth's outer core, generating electric currents. When the planet rotates around its axis, the electric currents form a powerful magnetic field. The sunward side of the magnetosphere is as large as 10 Earth's radii, and the other side stretches out in a magnetotail that spreads for 200 times the Earth's radius.
It happened long, long ago, and far, far away from our planet, all the way across the universe. A powerful burst of gamma radiation lasted a mere half-second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Watching this fading light, astronomers on Earth noticed a strange infrared signal. It was invisible to the human eye, but could be perceived as heat. After examining the phenomenon with X-ray, radio, optical, and infrared waves, the astrophysics team made a shocking conclusion. It seemed that people had finally seen a newborn Magnetar for the first time ever. This Magnetar was likely formed after two neutron stars had merged. It resulted in a Kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22nd, 2020. But I'm getting ahead of myself. How about we first figure out what these novas, magnetars, and neutron stars are? Imagine a massive star, at least 5 times the mass of our sun, reaching the end of its life. It might be because it's run out of nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1 million times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shock wave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas, called a nebula, expanding around it. If the star has been massive enough, more than 10 times the size of the sun, it's likely to turn into a black hole. By the way, when a star similar in size to our sun runs out of its fuel, it turns into a white dwarf. It expels most of its outer material, and only the star's hot core remains intact. Such a core usually gets heated up to 180,000 degrees Fahrenheit. A white dwarf is just a bit bigger than our planet, but half as massive as the sun. In other words, these stars are some of the densest objects in the universe. A white dwarf can be 200,000 times denser than the Earth. it usually takes a white dwarf over 1 billion years to cool down. Under certain conditions, such a star can erupt, and this event is called a nova. It's way less bright than a supernova or even a kilonova, which occurs when two neutron stars, or a neutron star and a black hole, merge into each other. Anyway, back to a supernova. If a star is large but not massive enough to turn into a black hole, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our Sun is almost 865,000 miles across, which is 109 Earths put side to side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our Sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. That's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When two neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's an exotic form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planet's. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. Neutron stars are weird and scary. Their interior is a never-ending dance of particles in extreme conditions. It results in unexpected and odd structures. For example, closer to the surface, hundreds of neutrons form blobs. Those are not unlike some weird kind of space nochi. They mold into long chains once you go deeper. Not that you'd ever be able to explore a neutron star from up close. These long chains look like a layer of spaghetti. Underneath, there's a region of even more extreme pressures. That's where our spaghetti turns into lasagna sheets, since we've started on this pasta comparison. Finally, under all these layers, even lasagna loses its form and becomes a shapeless mass. But even in this mass, there are some tube-shaped gaps. And don't they look like ziti? Another thing about neutron stars, they're spinning non-stop. And this spinning is fast, more than several hundred times per second. The fastest spinning neutron star makes more than 700 turns per second. That's 42,000 times per minute. Neutron stars also have incredibly strong magnetic fields. That's why, if there was life on a neutron star, it would be two-dimensional. The star's gravity is so powerful, it'd literally flatten anything on its surface. And if such a star had an atmosphere, it wouldn't spread up further than a foot or so above the surface. But if neutron stars are bizarre and spooky, magnetars are too, perhaps even more so. Thanks to their incredible magnetic pull, these stars would win in the strongest magnetic field competition, hands down. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. But that's not all. Even your molecules would change under the influence of the star's field. In the end, you'd kind of vanish. If a magnetar flew within 100,000 miles from our planet, it'd wipe out the data on every single credit card in the world. Astronomers have seen magnetars before, but they've never witnessed one getting born. After the light was first detected, scientists understood something didn't add up. They compared different kinds of observations. It turned out that the light spotted by the Hubble Space Telescope was 10 times brighter than predicted. This information made the scientists think outside the box. They realized an entirely new phenomenon was going on. The team had several ideas that could explain the bizarre brightness, but the most probable one was also the most eccentric. Before, scientists thought magnetars only appeared after massive stars exploded and left behind supermagnetized neutron stars. But now, they suppose a small number of magnetars may actually appear in a more peaceful way after two neutron stars merge. Scientists only know about no more than 10 magnetars in our home Milky Way galaxy. They don't know for sure what makes these stars so terrifyingly magnetic. Whatever it is, magnetars don't seem to last long. After 10,000 years or so, they return to a more familiar neutron star state. They're still extremely magnetic, super dense, but not so extreme. The closest magnetar people know about is 9,000 light-years away from Earth, in the constellation Carina. Astronomers think the original star was 30 to 40 times the mass of the Sun, which is a really big one. Another magnetar is 18,000 light-years away from our planet. It suddenly started to burst in 2002. Around 80 bursts were recorded within a 4-hour window. After that, the magnetar has never been active again. By the way, the researchers were also immensely excited about seeing a kilonova. It occurred when the two neutron stars supposedly merged. A kilonova is more than 1,000 times brighter than a typical nova. Before, astronomers had only one confirmed and examined event of the kind. But the kilonova recorded in March looked different, and it might allow scientists to explore the diversity they knew nothing about.
So, what's going on with all the news about the sun? Some say that the sun is getting angry. Well, what does that mean exactly, and should we be concerned? Frankly, yes, we should be concerned. It's generally not a good thing to get too much sunshine. The ultraviolet component of sunlight is harmful to the skin. That's why humans have adapted a spectrum of skin pigmentation. The more sunlight there is to protect ourselves against, the more pigmentation we need. Big floppy hats and, of course, bottles of high SPF oil-free sunscreen help too, especially for fair-skinned people. But what is planet Earth going to do? First, let's get a good estimate of just how angry the sun is likely to get. The sun usually goes through an active-calm-active cycle every 22 years, with highs and lows occurring every 11 years. Why that happens, no one knows, it just does. There's probably a reason, but scientists haven't figured it out yet. They do know that, with each cycle, the sun reverses its magnetic poles. That in itself is pretty astounding, especially when you consider that Earth hasn't reversed its magnetic poles in the last 600,000 years. Lately, the sun has been extremely calm, the calmest it's been in over 100 years in fact. That's unusual too. The active-calm-active cycle has turned into an active-calm-calm cycle. But that's changing, and it's why we are notifying Brightsiders about what to expect in the coming few years. The terms calm or active or angry refer to the amount of high-energy radiation that the sun gives off. Thankfully, the amount of visible light the sun gives off doesn't change very much. That would be a serious problem. If the sun were to get just 6% dimmer or brighter, the Earth would either freeze or fry. Observing sunspots is the easiest way to measure how active the sun is. The more sunspots that are visible, the more active the sun is. A graph, known as the butterfly diagram, tracks the 11-year period of sunspot activity. The butterfly diagram shows how sunspots disappear regularly from the surface of the sun and reappear regularly in other locations. NASA predicted that the present cycle of solar activity would be calm like the previous one. But it's starting to look like that is not the case. Presently, we are in solar cycle number 25. That's the 25th 11-year solar cycle since 1755, when record-keeping began. This cycle of solar activity is expected to peak in 2025. The Sun has already exceeded the number of sunspots NASA had predicted. So, it doesn't look like this solar cycle is going to be a calm one. It looks like we are going to have some very active sun-blasting radiation on Earth for the next several years. In early February 2022, 40 out of 49 SpaceX communication satellites in orbit above the atmosphere were destroyed by an explosion on the Sun. High-speed electromagnetic plasma gas from the Sun, known as solar wind, caused the Earth's atmosphere to compress, and Elon Musk's satellites lost their orbital integrity and crashed back into Earth. Sunspots look like dark spots on the Sun, but they aren't dark. They're just not as bright as the surface of the Sun. To get a better idea, take a lit 25-watt light bulb and hold it in front of a lit 100-watt light bulb. The 25-watt light bulb will appear dark. That's the same way it is with sunspots. Sunspots on the surface of the Sun almost always come in pairs. This is because sunspots are magnetic storms in the plasma gas of the Sun. One sunspot will be magnetic positive, and the other sunspot will be magnetic negative. Between the two sunspots, which can be many times bigger than the Earth itself, there flows an electric current that carries a fiery arc of ionized gas with it. Solar flares are something else we should be concerned about. They are powerful electromagnetic explosions on the Sun associated with sunspots. As the superhot plasma gas on the Sun churns and twists, it also twists the magnetic field lines in the sunspots. When these lines snap, a powerful explosion releases X-ray and gamma radiation at the speed of light. Visible gases are also released. Solar flares have a classification system according to how powerful they are. X-class solar flares are the most dangerous. This type of solar flare can cause radio blackouts across Earth and harm satellites, astronauts in orbit, and even passengers on high-altitude airplanes. M-class solar flares cause spectacular aurora at the north and south pole areas on Earth, while C-class solar flares have almost no effect on Earth. But solar flares are not the biggest explosions on the Sun. CME stands for coronal mass ejection, and these are much more massive than solar flares and more dangerous when they're headed our way. As the name indicates, coronal mass ejections are explosions that originate on the Sun's corona. They hurl millions of tons of hot ionized gases outward from the corona. The word corona is derived from the Latin word for crown, and it's the layer of thin bright gas around the Sun's surface. The corona of the Sun is much hotter than the surface of the Sun. The surface itself is about 10,000 degrees Fahrenheit, but the corona is somewhere between 1 to 2 million degrees. The why and how the corona is so much hotter than the surface of the Sun is another major mystery that scientists have yet to completely work out. A recent theory claims the corona is heated by sound waves and the Sun's nuclear reactions make a lot of noise. Project GONG, which stands for Global Oscillation Networking Group, was set up on Earth to monitor the sound waves on the Sun. Cool, huh? Turns out the Sun is ringing or oscillating like a bell. And we have 5 observation sites across the globe. One in India, Australia, one in the Canary Islands, one in Chile, and one in California, that keep a constant watch over the 10 million sound waves moving on and around the Sun. Now that the Sun is entering an active phase, we can expect to see more powerful CMEs heading our way. The gases expelled by the Sun are ionized and stripped of electrons by the intense heat. This causes them to form a proton storm that can travel through space at speeds of around 500 miles per second. These positively charged atomic nuclei will mostly be blocked or deflected by the magnetic field that extends around Earth. Our atmosphere is no help against a proton storm, although the last mile of air above the surface of the Earth stops the harmful X-rays from solar flares. The particle wind from the Sun can only be stopped by Earth's magnetosphere. We can look forward to some spectacular aurora around Earth's magnetic poles, and it's very possible that these aurora will extend down to the mid-latitudes when the Earth is moving through a coronal mass ejection. Currently, the United States has a space probe headed for the solar corona. Because the corona of the Sun extends outward for many millions of miles, the Parker Solar Probe, as it's called, is cruising 3.8 million miles from the surface of our star, or about 1/10 the distance to Mercury. The probe is experiencing temperatures of 2,400 degrees Fahrenheit, but it is also kept at perfect room temperature. A 4.5-inch thick carbon composite heat shield protects the telescopes and magnetometers in the probe that measure the intensity of the solar wind. The 5 antennae that protrude into the coronal gases are made of a niobium alloy, which can withstand the extreme temperatures of the corona. The recent double calm cycle of the Sun is a bit concerning when trying to predict how active the Sun will get this cycle. The sunspots completely disappeared for a long time from the entire surface of the Sun. It is as if the magnetic distortions we usually see on the photosphere of the Sun had collapsed into its interior. Intense magnetism is coming to the surface now and breaking through into the corona. The National Center for Atmospheric Research in Boulder, Colorado, is predicting that this solar cycle, cycle number 25, will be one of the strongest ever. The last solar cycle was very calm, with a sunspot count of only 116. The average is 170. But the prediction for this cycle is between 210 and 260 sunspots, which would be one of the strongest cycles ever. We stand to lose more satellites to a stronger solar wind. We can also expect electric grid overloads as the proton storm peaks in 2025. That means we should expect an interruption to our internet services as positively charged protons get into the wires, run into the transformers, and overload them. On March 12, 1989, a powerful CME hit Earth and created absolute havoc with our power grids. Will we experience anything of this magnitude in the near future? Well, stay sharp, Brightsiders.
All the stars we see, including our Sun, are in a balance of powers. Stars are very heavy objects, so they have strong gravity, which presses them from the outside and makes them shrink. But inside a star, while it burns fuel, there are nuclear reactions that produce incredible amounts of energy. This energy is the light and heat that we feel during the day. But most importantly, these reactions increase the pressure inside the star and create a force that is fighting with gravity. So as long as the star has a full tank, it's safe. But then, the fuel runs out, the pressure inside the star falls, and the gravity wins. A star the size of our Sun can shine for about 10 billion years. Specifically, our lovely Sun is about 4.5 billion years old and has already burned half its fuel. The next stage in a star's life comes when it runs out of juice. Internal pressure drops, but gravity continues to press. At some point, a star simply collapses under its own weight and shrinks to the size of its core at the speed of almost a quarter of the speed of light. In less than half a second, a huge star turns into a small and dense object. This rapid collapse creates incredible shock waves that cause the upper layers of the star to explode. Now, an incredible amount of energy and matter is thrown into outer space. At this moment, luminosity of the star increases millions or even billions of times. This is the flash that our scientists can see with super powerful telescopes. But the light from this explosion doesn't reach our planet until many years later, so in fact, this star has long since faded. There are several options at this point. It all depends on the size of the star. If its mass is small, about the mass of our Sun, then for several months, this flash will become brighter and brighter until it reaches its peak. Then, the energy of the explosion will begin to dissipate, gradually fading and cooling down. A few years will pass, and the temperature of the former star will match that of space, and it will simply cease to exist. But the heavier the star, the more interesting the events will be. Heavy stars burn their fuel too quickly and have a much shorter lifespan. Stars weighing about 8 masses of the Sun can collapse into a rather unusual object, which is rarely found in the universe, a neutron star. This dull ball is only 6 to 12 miles wide, and covered with a hard metal crust about half a mile thick. Neutron stars can weigh about 2 suns and have a strong gravity force. If you feel comfortable and in good shape on Earth, you wouldn't even be able to lift a needle or a match here. What's more, you would be pressed to the surface like a pancake and just unable to move. But there are stars dozens of times heavier than the Sun. An explosion of such a supernova, which weighs at least 40 times more than the Sun, gives birth to the most inexplicable and mysterious object in the universe, a black hole. At first, an incredibly bright explosion occurs. A shockwave spreads, carrying dust and matter of the former star around like a fog. And at the place of the explosion, only a small black disk is left. This black abyss is the heaviest object in the universe. It's so heavy that its gravity curves space-time around it. Yes, the closer you are to a black hole, the slower time will go for you. If you could get close enough to one of them, spend a couple of minutes in its orbit, and return to Earth, you would simply not recognize your home. 1 minute near a black hole can be a month, a year, or a decade on Earth. This depends on how heavy the black hole is. But don't get too close. The force of its gravity is so strong that even light can't escape from it. Humanity also knows about the existence of supermassive black holes. They gradually build up their mass, feeding on different cosmic objects just like a predator. Usually, such supermassive black holes lie in the centers of galaxies, and their gravity is so strong they can hold countless stars near them. For example, this is the only photo of a black hole, which is located in the center of the Messier 87 galaxy. The orange glow around it is its event horizon. That's the remains of the light from the objects this black hole has swallowed. You're quite safe though. The closest black hole is 1,120 light-years away. But supernovae can explode not only when gravity wins the fight with the star's internal forces. Sometimes the opposite happens. The nuclear fusion inside the star begins to affect much more matter than normal. The pressure inside a star increases, and it defeats the force of gravity that exerts pressure on the star from outside. At this point, there's a boom! This never happens by itself, and this type of supernova is only possible in binary star systems. 2 stars are spinning around each other. One star begins to swallow the substance from the other. Then, the nuclear reactions inside it are no longer in balance, and a supernova explodes. For some time, scientists believed that such an explosion could occur in 2022. There's such a binary system in the Swan constellation at a distance of 1,800 light-years from the Sun. The luminous red nova should have occurred here. Such a red flash would have been visible to the naked eye for months. And after the explosion itself and the merger of 2 stars, a new, hotter, and heavier star was to appear in their place. But a new analysis of the data revealed a calculation error, and this event will not happen soon after all. So now we see that a supernova explosion is a very dangerous event, and it can cause great harm to our planet if it happens close enough. The main danger is gamma rays. This is the radiation that comes from the explosion. When these rays reach the Earth, they affect our space shield, the atmosphere. They reduce the ozone layer and make us vulnerable to solar radiation and cosmic rays. In this case, all life on the planet is in incredible danger. And the bad news is that such an explosion could happen quite soon. Betelgeuse, the brightest star in the night sky, about 17 times larger than the Sun and 8.5 billion years old. It's begun to exhaust its fuel reserves. Scientists predict that this giant will explode like a supernova at any moment within the next 10,000 years. so it may happen in a few centuries or even tomorrow. Everything will happen as follows. Betelgeuse will collapse in a fraction of a second, and then it will explode so brightly that it will look like a second moon in the night sky. We will observe a new bright spot in the sky for weeks or even months. But then, it will begin to fade until it completely disappears. Not without a trace, though. In its place, there will be a neutron star, weighing 1.5 times the Sun. It will be one of the biggest events that humanity has ever seen. Still, we have nothing to be afraid of. Betelgeuse is about 550 light-years away from us, so its X-rays and ultraviolet light will not affect us. A much greater danger is posed by the release of material that occurs in a supernova explosion. But this shouldn't make you worried either. The shockwave won't reach the Earth until 6 million years later, and it will be suppressed by the oncoming solar wind. So if we see Betelgeuse explode today, it will be an epic sight. But in fact, the star will not exist at the time, because it will mean the event itself happened almost 6 centuries ago. It's just that now the light from it has reached us. Some scientists believe that the Ordovician Silurian extinction events, which occurred almost 500 million years ago, happened exactly because of a star explosion. Then, almost 60% of marine vertebrates went extinct. Yet, it was not a supernova, but a hypernova. That is what scientists call explosions of stars 100 to 150 times larger than the Sun. In addition to the abnormal weight, the star must rotate very quickly. Such objects are very rare. In our galaxy, there are few of them, and scientists believe that hypernovae occur about once in 200 million years.
You're sitting on the balcony, fiddling with your phone, when suddenly, everything around you starts to turn to dust. Gaping, you put your phone down. You see cars, bicycles, sidewalks, street, and traffic lights disappear right in front of your eyes. People in the street are panicking and running in different directions. You glance at your watch, and it vanishes too. You turn to look at your room through the balcony door and see that all your furniture is turning to dust. You look back at the street and see nothing but a dust storm. Your house starts shaking. You run downstairs and stand in the middle of the road. You're just in time to see the buildings in your neighborhood fade away. You tried to get into your car, but in the next moment, there's nothing in the place where it was standing just a second ago. You check your phone and see several notifications about the world going on a full reset. Everything humans have ever created is now disappearing. You're still holding your phone when it gets lighter and lighter, until it's completely gone. The same process is happening all around the world. The Eiffel Tower, the pyramids of Giza, the Empire State Building. They have all vanished. You tried to find somewhere to hide until this disaster ends. 2 years later, you wake up in a cave, together with other people. Everything humans have produced throughout the centuries of hard work has disappeared from the face of the earth. Everything that's left behind is people, animals, and nature. Your city is now a massive plain of barren land with a few trees scattered here and there. Your community consists of your former barber, a comic book store manager, local baker, and your neighbors and friends. You head out of the cave to pick up some crops you planted earlier in the season. There's not a building in sight that would obstruct your view. You can see the mountains miles away. That's where the nearest town used to be. And over there, that's the ocean where you once went jogging by the bay. The land is swarming with wildlife. Plenty of raccoons, badgers, possums, and wild cats roam the neighborhood. Next to your tiny garden, there's a large bonfire where you cook food and have your night gatherings. Not too far away, you can see a well. Once, there was an old piping network down there. But when the world reset, it disappeared. The only thing that remained underground was the water that you now use for drinking. Your local police officer is the leader of the community. He stands on a log and says you've only got a week left before the water runs out completely. You'll need to move to another location with a new source of water. You finish your work and take a quick nap because you're on night duty. You walk around the perimeter. There's no light pollution anymore, and stars are gleaming above your head. 2 other people are also patrolling the area. Suddenly, you see something running in the distance. You look closely and spot a fox. It's heading to your chicken coop. You run toward the animal and shoo it off. Finally, it's the moving day. Everyone packs their stuff in bags made of rope and begins walking. You've got only 1 horse carrying supplies and water for everyone. It's going to take around a week on foot to reach the lakes. You make your way through the plain, which used to be a highway leading to the next state. It's scorching hot, and your group is moving very slowly. Along the way, you meet other nomadic caravans that trade goods with you. At night, you set up camp next to an old gas station. The building is gone, but the foundation is still there. A week later, you finally make it to the mountains near the lake and enter the forest. You have to walk uphill almost all the way. Soon, it gets too dark. You have to make camp under the cover of old trees. It's a cold night, and the members of your group gather around a campfire. You're back to your night duty when everyone falls asleep. You scout the area and hear some growling sounds. You look around and spot a bear. You duck down and try not to make any noise. Suddenly, you notice that next to you, there's a little bear cub. It's curiously sniffing the air just a dozen of feet away from you. The mama bear roars, calling its kid. You back up slowly. Everything is fine until you accidentally step on a branch. The cub starts wailing. Its mom leaps out from behind the trees and spots you. The massive creature stands up on its hind legs and roars. People in the camp wake up in a panic. You run back with the bear right behind you. The leader and the rest of the night patrol manage to scare the furious animal off. You've got tons of experience with foxes and raccoons, but bears are a whole new thing. You realize that you're not at the top of the food chain anymore. The next day, you proceed with extreme caution. Lots of wild animals, like mountain lions and bobcats, are lurking around. You finally make it to the other side of the mountain and see the lake. It's a large area that used to be a public camping spot. Now, there are a couple of settlements built near the water. Your community isn't that big. That's why you settle near the river flowing out of the lake. You build a hut next to the waterfall and continue to work as a farmer. You meet amazing people from other settlements. They used to be scientists, engineers, musicians, doctors. The scientists are trying to figure out a way to rebuild the society based on technology, but it's likely to take decades. They've made the first step by creating a clay oven, pots, and pans. They've also built a dock on the lake and canoes for fishing and transportation. A couple of months pass. You've constructed an irrigation system that uses lake water. The engineers in the settlement have even made a piping system. It delivers fresh water to every house. Now, these specialists are constructing a small dam to generate electricity, but that might take months to do. The settlement is growing bigger with each next week. New huts are being built all the time. A carpenter has created a workshop to make furniture and tools. You no longer have to be on night duty and can focus entirely on your crops. Ever since everything humans had created vanished, people have been much healthier and stronger than before. No one sits in their hut with their eyes on the phone or TV screen. The smog that used to cover cities has disappeared. Marine life is thriving. There's no pollution. And trees are now growing in places that were once deforested. Everyone travels on foot or by horses and donkeys. People have been breeding these animals for transportation, so there are plenty of them around. And the economy has changed, with everyone offering their labor in return for food or other things they need. All people have to contribute if they want to live in settlements. There are some nomads who stay alone, but it's not easy to survive in the wild without help. That's why these people mainly work as merchants. They deliver goods between settlements that are too far away from one another. To entertain themselves, people role-play parts of old classic movies in front of an audience. Someone managed to make guitars, flutes, and percussion instruments from scratch. Now, you can listen to concerts at night. You find a beautiful spot to do some drawing. You use natural ink and leaves instead of paper. Suddenly, you spot something sticking out of the ground. You pick it up and examine the familiar, almost perfect shape. In a moment, you're already rushing back to your hut to wash off the dirt. Someone tries to check what you're doing, but you make sure no one sees your find. Finally, it's clean. Your suspicion is confirmed. It's a smartphone. It's the first evidence of the past technological progress which hasn't disappeared. You try to get it to work, and the gadget actually does turn on. You read a text on the phone, and it reveals the truth behind everything created by people turning to dust.
What if the sun, our precious source of light and heat, got swallowed by a black hole? Or even more worrying, what if such a black hole was brewing inside our star right now? Would the sun eventually collapse in on itself, pulling along everything in the solar system? Well, if a medium-sized stellar black hole, formed by the gravitational collapse of a star, swallowed the sun, we would only have around 8 minutes before things went haywire. But if our star swallowed a tiny primordial black hole, we could probably have a chance to survive. The existence of primordial black holes hasn't been confirmed yet. These hypothetical black holes are believed to have formed right after the universe was born. Unlike supermassive or even stellar mass black holes, primordial ones are typically tiny. Their mass is roughly the same as the mass of an asteroid, and their size is no larger than that of a baseball. You can find primordial black holes in a few theoretical models, which have been used in attempts to explain loads of mysterious space stuff, from hypothetical planet X to dark matter. There's actually a theory that primordial black holes could actually be dark matter. If primordial black holes indeed existed, they could appear because some regions of space were hotter, others were cooler, and some areas were extremely dense. Scientists believe these dense spots could collapse into primordial black holes. The most curious thing, though? These holes might be so small exactly because they popped up right after the Big Bang. The thing is, the longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes was incredible. Compare the mass 1,000 times greater than our sun's and that of a pea. There you go. By now, the smallest primordial black holes have most likely evaporated away, but some bigger ones can still be scattered out there in space. Many theoretical models claim that primordial black holes are so common that it's kinda inevitable for a random star to capture one. Such stars with black holes at their centers are known as Hawking stars. So, what might happen after such an accidental acquisition? At first, a captured primordial black hole isn't likely to have any effect on a sun-like star. After all, compared to our massive star, an asteroid's worth of mass might as well be a speck of dust. The black hole simply isn't able to consume much of the sun, but with time, its persistent presence in the heart of the star can start affecting things. The black hole is likely to begin consuming matter in the stellar core, growing over time. If this process is fast enough on a cosmological scale, the black hole can end up swallowing the star completely. If the process is too slow, it might still influence the development and lifespan of the star. Mostly, it depends on the initial size of the primordial black hole. A large one with around 1/1000th of the solar mass can potentially consume a star in less than 500 million years. If something like that has ever happened, there must be solar mass black holes out there, too small to have been created by supernovae like regular stellar black holes. If the primordial black hole is way smaller, 1/1000th of the solar mass, things might get complicated. This tiny hole will keep munching on the star's core, but at a very slow pace. And still, it will stir things up in the core of the star, making it heat up more than usual. Eventually, the host star will swell into something cooler and redder than usual red giant stars. Plus, the turbulence at its core is likely to affect the surface activity of the star. Since we haven't observed anything like this happening to our sun, it's very unlikely that there's a primordial black hole at its center. But we can't say for sure that there aren't other stars hurtling through space, carrying primordial black holes in their hearts.
From where we stand, the sun seems so calm and peaceful. But like humans, and basically the whole living world, the sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the sun becomes hyperactive. Let's zoom in to see what's happening up there. So one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our sun is. And it seems the sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the sun's surface. The last time we had so many dark patches across the sun was in September 2002, when there were 187 of them. Uh-oh. It seems this chaotic party is getting closer to its peak. And that's something we call solar maximum. How does all this even happen? The sun's magnetic field is strong and organized at some point. But as we said, sometimes comes the time when it kind of ends up tangled, sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares and something we call coronal mass ejections, CME. That's when plasma in the sun's upper atmosphere, called the corona, goes crazy and bursts really strong. Then at some point, this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so. So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active. A thing called plasma waterfall or polar crown prominence, PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall's really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit. And it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the aurora borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere, and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure, like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you, but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before. And when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked. Operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. But it brought something incredible, 2 stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year. Plus, the strongest ones, X-class flares, have been getting stronger and more common than before, too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort Cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli-Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli-Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli-Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli-Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli-Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli-Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
Of fire and smoke fly upward, and the rocket launches. The Delta IV Heavy is one of the most powerful rockets people have ever made. 3 massive engines burn tons of fuel, helping the spacecraft gain altitude. The 2 side boosters undock, leaving the common booster core for further ascent. When in orbit, the rocket releases its payload. This is the Parker Solar Probe, the first spacecraft to touch the sun, and we'll follow its journey step by step. The probe was launched on August 12, 2018, and began its journey toward our star. The sun is 93 million miles away from Earth. That's 390 times the Earth-Moon distance and 36,000 times the width of the United States from coast to coast. The particles of light that the sun emits need 8 minutes to travel this distance. For our conventional rockets, that journey would take more than 200 days. But the Parker Solar Probe covered it faster, using gravitational maneuvers. On its way from the Earth to the sun, the probe circled around our neighbor, Venus. All it had to do was enter the planet's gravitational field and let it attract itself. At this point, our space probe got an extra boost, and it didn't need to waste any fuel. After making one orbit, the space probe's engines changed the trajectory, and the probe left the orbit of Venus. It got enough acceleration to travel to the sun. And on November 5, 2018, the Parker Solar Probe made its first approach to the sun. Before touching its surface, the spacecraft had to enter the star's orbit first. To achieve this, it did even more gravitational maneuvers. Only after that did it start circling the sun, the heaviest object in the solar system with the most powerful gravity. So, it'll give the probe an incredible amount of acceleration with each flyby. The Parker Solar Probe was constantly moving between 2 points. Those were the perihelion and aphelion. Look, here's the sun, and here's the probe's orbit in the shape of an ellipse. The closest point to the sun is the perihelion. The sun was pulling the probe there at an incredible speed. At this point, the probe began to move away from the star. It still had a lot of speed and energy, but it was struggling against the gravitational force of the star. So it gradually slowed down. The point where the probe lost all its acceleration is called aphelion. The star's gravitational force won, and the probe began to move back toward the sun, picking up speed again. The probe made several circles following a stable orbit, But then its orbit intersected with that of Venus again. Another gravitational maneuver, and after that, the Parker Solar Probe's trajectory shifted slightly, and it gained more speed. The perihelion point of its orbit was now closer to the Sun. The probe made several more circles following this new orbit. Then again, it neared Venus. Another approach to the Sun. Each encounter with Venus corrected the probe's trajectory and gradually reduced its distance from our star. In April 2021, the Parker Solar Probe finally came so close to the Sun that it touched its corona. Although the actual distance between the probe and the Sun was 5.3 million miles, that still counted as a touch. Let's look at the structure of our star by cutting it in half. This is the core of the Sun. It's about a quarter of its width. The core is 150 times as dense as water. Because of the intense pressure and high temperature, nuclear reactions occur there. Hydrogen gets converted into helium, giving off an incredible amount of heat and radiation. The next layer is the radiation zone. This is where the heat is transferred from the core to the next layers. But the photons here don't move in an outward direction. They can be directed anywhere and re-radiated many times. Scientists believe that the average time it takes a photon of light to travel from the core to the next layer of the Sun is about 10,000 to 170,000 years. Then there's the convection zone. This is what's considered to be the surface of the Sun. But it's not a solid surface. It's an ocean of hot plasma. It looks like a bee honeycomb. That's because the heated plasma rises from the lower layers, creating something like mini geysers. And while it's still hot in the middle of those geysers, their edges cool down, creating an amazing pattern on the Sun's surface. The next layers are the Sun's atmosphere. First, the photosphere. This is the layer that gives off light. And that's exactly what you see when you look at the Sun. But careful, don't do that. You need special equipment to look at our star. The photosphere is up to 250 miles thick. This is about the height at which the International Space Station moves above Earth. Then, the chromosphere, or the sphere of color. This layer of the Sun's atmosphere gives the star its reddish hue. Solar prominences appear here. Those are powerful emissions of matter leaving the surface of the Sun. Their speed can reach 430 miles per second. At some point, they get caught by the star's magnetic field and pulled back. And then there's the corona, a gaseous envelope of the Sun. The most powerful ejections take place there. You can see the corona during eclipses, when the moon covers the solar disk. Then you can notice some kind of glow around the star. This is the corona. It extends for millions of miles around the Sun. And the Parker Solar Probe touched precisely that area. That's where solar material and radiation are still tied to the star's gravity and don't fly off into space. And all that is beyond that area is the solar wind. It's the material and radiation that managed to escape the Sun's gravity and set off into space. The Parker Solar Probe surprised astronomers by providing more information about this boundary. It turns out it's not a perfect circular wall like we used to think. The boundary is broken and uneven. It looks more like a mountain range. These bumpy regions have such a shape because of the uneven flow of plasma from the surface of the Sun. The larger and more powerful the flow, the farther the boundary is from the star's surface. But scientists don't know yet what exactly causes this difference. After making the flyby around the Sun, the Parker Solar Probe continued its journey and started to move away from the star again. Researchers are expecting another 4 approaches in 2022. In August 2023, the probe will make a flyby around Venus. It'll gain more speed and approach the Sun at a record close distance. The next Venus flyby will happen in 2024. And hopefully, the Parker Solar Probe will be able to withstand the high temperatures and radiation so close to the Sun. Luckily, scientists have taken care of that. The probe has a solar shield. It's attached to the side of the probe that will face the star. It's about the size of a house window and about 4.5 inches thick. It's made of a special material that can withstand a temperature of about 2,500 degrees Fahrenheit. That's almost 6 times higher than the temperature of a regular kitchen oven. The body of the probe is made of a white material that reflects sunlight. All the scientific equipment is placed right in the center of the shadow of this shield. If the Sun's rays hit the unprotected body of the probe at close range, all the equipment will be out of action in just a few tenths of a second. The Parker Solar Probe is equipped with the Electromagnetic Fields Investigation Instrument. This is a system for measuring electric and magnetic fields, radio waves, temperature, and plasma density. The Wide Field Imager for the Parker Solar Probe, or WISPR, is an optical telescope, the one that took those stunning images of the moving plasma in the sun's corona. These streamers are what you see during solar eclipses. The Solar Wind Electrons, Alphas, and Protons investigation measures protons, electrons, and helium ions. It helps scientists study solar winds. It often harms our technology. Unexpected flares on the surface of the sun can cause severe solar winds. They can burn chips and satellites orbiting Earth. Given that we have the ISS, where people work all the time, we need to know more about solar winds and how to protect ourselves from them. While the Parker Solar Probe continues its research, it's already set several world records. It's the closest to the sun human-made object. It's also the speed record holder. During its final approach to the sun, the probe reached a speed of 101 miles per second. That means it could cover the distance from New York to Los Angeles in just 24 seconds. And a trip around Earth would take about 4 minutes. A journey to the moon in such a spacecraft would only take 40 minutes. In 2025, the Parker Solar Probe will make its closest approach to the sun, reaching a speed of about 430,000 miles per hour. But even this speed is only 0.064% of the speed of light.